So today's session has been designated to be the participant to do something, and I will be a guide. So I've posted two problems to the page. The first one in picture form will be something that you do and submit it today, and the last one will be submitted tomorrow. And per the last one, I will give you guidelines on how you are going to do it in picture form. I will send all those ones to the page, so it will be easier. So I want to congratulate you for being up to this far. Or if you have any question at all regarding what you have done so far, within the space of 5 minutes, we can talk about it before you start with your work. So within the next hour, you save your work as PDF, export the results table to the main flow sheet, and submit it to the page. Yes, remember to add your name. Remember, you will be awarded a certificate that you are familiarized with ASPEN Plus. So get that in mind. So if you have a question, you can let us discuss it before I move on to read the problem and commission you to start. Please, do you have a question? Okay, so the question can be general question if the general question on what we have done so far. Or you can unmute yourself and talk. Maybe even somebody can even give you help. Today, I think some of our people can help to answer the questions. So the outline was to introduce the general overview of ASPEN simulation software. I think that has been covered. Fluid handling equipment have been covered. Heat exchanger equipment have been covered. Chemical reactors, yes, stoichiometry, equilibrium, and kinetic base has been covered. Separation processes, that's the model that we use for separation, was covered yesterday. And today is plant-wide simulation that you are going to combine whatever you have learned and do it and submit. Okay, Edu. About the column internals, when I was doing it, I saw that when I used the sieve packaging, I was getting errors in the column, but when I change it, the packing error left. Okay, so depending on the feed that we are using, you said you were using sieve packaging and it was getting errors. Right, okay. I try using C packaging here and it got, you try to do it with C packaging, but what this time around, what you do is when you come to the ASPEN Plus interface, make use of the reset, reinitialize it, reinitialize everything and run it, and let's get the feedback. All right, thank you. All right, Dugan, you can talk.
Master Clinton.
Boss.
Yes. So with the colon internals, I also add errors, but with I use the tray sieve something. So I try increasing the diameter of the colon, and that thing got resolved. So I think when the diameter of the colon is increased, I think you'll be able to, resolve that.
All right, thank you. So Edu, I think this is a good answer from Isaac Dugan to you. All right, okay. Thank you, Dugan. Is any other questions? Okay, so let me read the problem that we are doing today. Okay, I mean, let me see here. Okay, so the problem is around toluene production. So a fresh feed of 20 pound mole per hour of pure N-heptane at 77 degrees Fahrenheit and 1 atm is combined with a solvent recycled from an extractor and heated to 425 degrees Fahrenheit at 1 atm. The hot stream is fed into a reactor in which the following reaction occurs. And there is the reaction. N-heptane decomposes to toluene and hydrogen. The conversion based on N-heptane is 15%. The product of reaction are cooled to 180 Fahrenheit, after which the hydrogen is completely separated from the reactor products in the first separator. A feed of 100 pound mole per hour of benzene at 180 degrees Fahrenheit and 1 atm is combined with the remaining products of reaction to extract the toluene. All of the toluene and benzene leaves the product in the product stream of the process. The unreacted N-heptane is recycled to the mixer. A sketch of the process is given below. So our stoic model for the reactor and the property method is called SEDA. That's the property method. So in today's work, you are just going to do this simple plan for production of toluene. So you have the first one is a mixer, and you have a heater, R stoic, a heater, a separator. That's when you come to the separators. When you come to separators, you choose this sep, and I'll show you how you are going to do the separation from here. This is the work that I did that I'll be comparing it with what you will send. So this is the separator that you will choose sep, and you can choose to just take sep or and give a name to it, or you can do it as it was given in the problem, just like this. So in the separator here, you separate the hydrogen from the remaining N-heptane and toluene. So in this one, you are going to add benzene to the mixture to one separator. So it's going to act like an extractor. Then you are going to send it down. That will be the product, and you will send this one back to the mixer. So in doing this, when we started, I told you ASPEN is a sequence modeling simulation tool. That means ASPEN is going to solve the heater and use the results to work for our stoic, and the results will be heated. Then it will move up to separator to this side before we get the recycle stream back. So when you are doing it, what you are going to do is that you are not going to start with a mixer. You are going to start with the first one, which is A. The A, and the A is going to be the feed. Or better still, you can start with a feed. So let me go to my diagram. So when you come here, all that I'm saying is that you are not going to start with this one, this first one as feed, but what you are going to do is that, okay, so what you are going to do is that, let me break this one. This will be a tier stream. You are going to remove the stream from the mixer like this. All right, so like this, then I run. You see that I'll get my results. My results is available. And this one too, you can decide to go start with a mixer and do it, but it will just be like a tank. You put the feed in and it will go. Then later on, you bring the recycle stream to connect back like this. Then when you are done, you can reset everything and run. All right. So now that you see that it's done, everything has been calculated, and you see that the everything will change. It will take the recycle stream back, and it will do the material and energy balance based on the stream that you have already introduced. So I guess this is very easy that you can do it as a simple plan. Then later on the assignment, I will send guidelines to you so that you are going to do it by yourself. So the only thing that we haven't touched, that will be the separator. So after you have produced the product, which is from the problem, the product which is toluene and hydrogen, you will send it to a separator. And how you are going to specify the separator, let me see, double click on the separator. Here we have toluene and hydrogen in it. So the stream that you want the part of the mixture to go, you just specify that one as 1. That means 1 means 100% of hydrogen should leave in this outlet stream, which is G. That's it. So once you just select that, it's okay. You don't specify for toluene and run. Your results will be available. The same thing applies to this side. So for here, what I did was I just specify I needed to take heptane from the mixture of toluene and benzene. So just select that, and that will pass through the recycle stream. The outlet stream that I wanted to pass is this one. So whilst doing it, don't just connect this one for the first time. Wait. Make it be a tier stream like this, a stream that's not attached. It's not a recycle. Then let me reinitialize and run. So all right, so everything is done now. You saw just a glance, everything has been calculated. So now you can see the stream results. Let me go to modify. All right, so the mass flow rate, this is the mass flow rate. So we are going to add this 77 kilogram per hour of the heptane back to this one. Then we are going to compare the results that will be given. So let me just add it. Let's see what will happen. Okay, I reinitialize and I run. All right, so the first one, the hydrogen that was given was 100. The hydrogen that was given was 11 kilogram per hour. Now we have put in a recycle stream, and now you can see that it has moved from 11 to 73. So that will be the problem, and specification of the R stoic reactor. That's just what we have done. So it's going to be 475 degrees Celsius, and the pressure is 1 atm. 1 atm. So I'm going to take a snap of this and put it to the page. So where did I reach? All right. So I'm taking a snap of this and send it to the page so that you just look at the configuration. Just look at the configuration. So I'm just going to send you the attendance sheet so that you do it. All right. Okay. It has been sent. Right. It has been sent to the page. It has been sent to the page. So um, I'm giving you the attendance sheet so that you sign the class. Me use Wi-Fi is here. Sorry. All right. So the attendance sheet is here. Uh, Jero, 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 bravo. Acaba, não. Atiko, Atiko. Or we had a technical problem here that we needed to resolve. So I'm going to post the attendance form to the page. Then you fill the attendance form. Fill the attendance form and do your assignment and submit it by the end of the meeting. The meeting will end at 5, so by the end of the meeting, just fill and compile your results in one PDF and submit it. Please, if you have any questions regarding what you are going to do, let me know. Okay, so let me sign up. All right, so I have signed up for the last day. I hope you do too. So, okay, so okay, this is your problem that you do. For the extractor, we are just using a separator to represent an extractor. So what you do is that What you do is that we want to um, you have mixed benzene with the product that are coming from the step one. So in the step two, what you do is that you just go to the step and you choose the split fraction for the heptane to be 1 in the recycle stream. That will be all. It will be done with that. But just as I told you how we do uh, extraction, the column that you are going to use, you can do the absorption and all those stuffs here at the rad frac. Yes. So the assignment contains one of these, and I'll guide you to do that. Began, are you okay?
No, I'm not okay.
Do you understand the first one, the first separator?
Yes, I
Okay, so
understand.
okay, so you will do same for the second separator, but this time around, you see that we have three components. So you will choose
Yes.
the split fraction for the stream that you want it. So let me go to the. So you come to the setup. The split fraction for heptane is 1 into the recycle stream, and the recycle stream is this
Clinton,
one.
please are you sharing your screen because I can't see anything?
Okay.
All right, I'm sorry. All right, so what I was saying is that you specify the other step which we are using as an extractor. Uh, all right. So you specify the heptane into the recycle stream just as for the first step, and that will be all. Then later on, we discuss the assignment. I'll send you guidelines on the page so that you do it and submit it. So at this stage, your stage in ASPEN plus now, you should be able to do it alone without any but these guidelines. So there is the guideline, and we expect you to be able to do it and submit the results. But don't hesitate to share your problem on the page. Maybe one of us will help you and you do it. Yes, I will be active on the page. So when you share your problem, I will be there to assist you. Okay. So the assignment has started now, so you can join. So I'll be here. If you have problem, you can share. Then that will be it. Thank you very much for your cooperation. Thank you. Yes, yes, please, Dugan. So this is a shortcut approach, a problem that I'm giving it to you to do. Yes. So upper extraction is done using the columns. Just to test your understanding in this bootcamp. Okay, so I am around till this first meeting will end. So this will be the end, and you can chat me afterwards. afterwards. Then make sure you submit your assignment to the page. Thank you very much. So I will be here till this first meeting ends. So after this first meeting, new one will not be created, but I'll be waiting for your results in the next hour. Thank you very much. And your assignment is due tomorrow by 6 p.m. No, 6 p.m. is too early. Let me say by tomorrow. So anytime tomorrow. Yes. If you submit 11:59 p.m. is fine. Okay. Thank you very much.